Hello everybody and welcome back to Unit 8 of Regents Chemistry where we are talking about reactions and stoichiometry. Today we'll talk about the last part of this chapter, which is about percent composition. And you guys will basically just learn how to determine the percent composition of different elements in a compound. So you guys will be specifically learning about how to calculate the percent composition by mass of any element in a compound, which means if you take the mass of the element, you take the mass of the compound, and then you figure out what is the percentage of that element in the compound based on the mass. The good thing is the equation that you'll be using for this is given in table T. Pretty simple, pretty easy. You basically just take the mass of the part, which means the mass of the element or whatever you're looking at, and you divide that by the mass of whole, which is the mass of the entire compound, and you multiply that with 100. So let's say this is the question that you're given. What is the percent by mass of magnesium in magnesium oxide? So magnesium oxide is your compound, and you have to figure out the percentage by mass of magnesium in this compound. So first of all, you calculate the mass of the part, which is just the magnesium. You go to your periodic table, you figure out the mass of magnesium, which turns out to be 24 grams per mole. And then you determine the mass of the whole compound, which is magnesium oxide. So the mass of magnesium is 24, the mass of oxygen is 16. We only have one mole for both of those things. So that's why we don't need to multiply them with anything, just 24 plus 1. And the overall mass of the compound turns out to be 40. Now we just need to plug in everything in the equation. Percent composition will be equal to 24 grams per mole for magnesium divided by 40 grams per mole for magnesium oxide times 100. Just do your math, and the answer turns out to be 60%, which means magnesium is 60% of magnesium oxide. As simple as that. Now sometimes you guys do get some questions where you have this compound called the hydrates, and you have to find the percent composition of either the water part or something else in that hydrate compound. So basically in a hydrate you have a regular compound and it has a water molecule incorporated in it. You guys have definitely seen compounds like this. These are called the hydrates. So here you have a regular compound, which is calcium sulfate, CaSO4, and it has two water molecules incorporated with that. Now, we have definitely practiced, when we were talking about the molar mass, we have practiced how to calculate the gram formula mass or the molar mass of these compounds. So basically, that dot in the middle, even though it indicates that, this water molecule is attached to this calcium sulfate, just remember that that dot is not a multiplication. When you are calculating the molar mass, you basically, that is just equal to a plus sign. So we add the mass of everything just like we do regularly whenever we are calculating the molar mass of any regular compound. So in that, if let's say you take out that water part from this molecule, so in CaSO4, when it's in the hydrate form, if we let the water evaporate, that H2O part will be gone, and we are only left with the CaSO4, and that now will be an anhydrate, which means we just got rid of the hydrate part from this compound. So let's practice how can we calculate the percent composition whenever we are dealing with hydrates. So we do the same old thing. We calculate the mass of the whole and the mass of the part. So let's say here's a question and it's saying calculate the percent composition of water in this calcium sulfate hydrate. So first of all, you calculate the mass of the part, which is your water part. We have 2 moles of water, so make sure that you're also taking that into account when you are calculating the molar mass or the gram formula mass. So hydrogen has a mass of 1, and we have 2 times 2, 4 moles or 4 molecules of hydrogen. So 1 times 4 there, and then oxygen has a mass of 16, and we have 2 times 1, 2 moles of oxygen. So this is how that is going to be written. 1 times 4 for hydrogen plus 16 times 2 for oxygen. We add all of them, and the mass of water will be 36 grams per mole. And then we have to calculate the mass of the whole thing. So we start with calcium. Go to your periodic table. The mass of calcium is 40. And we only have 1 mole of calcium there, so that would be 40 times 1. Then we do the same thing with sulfur. We have the mass of sulfur is 32. We only have 1 mole of sulfur. Plus, next up we have oxygen. The mass of oxygen is 16, but please take into account the total number of oxygens that we have there. So we have 4 oxygens in the first part, in the CaSO4 part, and then we have 2 oxygens in the second part. So 4 plus 2, overall we have 6 oxygens. Plus, finally, we go to hydrogen. The mass of hydrogen is 1, and we have 4 hydrogens. So now plug everything in your calculator, and the mass of the whole compound turns out to be 172 grams per mole. So now you can just use the same equation that we used before for the percent composition by mass. So that would be the mass of the part, which is 36 grams per mole, divided by the mass of the whole, which will be 172 grams per mole. Plug that and times 100, definitely, because it's a percentage. And then plug everything in your calculator. The final answer turns out to be 20.9%. So that is how much water you have in this molecule when it's a hydrate. Now, when that water is evaporated and we only have CaSO4 left, that will be an anhydrate because the water is gone. Alrighty, so that was it for Unit 8. I'm going to peace out with that. Take care, guys. I'll see you in the next unit.